Hello learners, welcome to Black Slides. This is a platform where you can visit and learn science subjects including mathematics all for free. Right, so mostly we present lessons, quality lessons to students doing managed syllabus, but those doing other curricula can also visit this very platform and pick up the bits of the content that relates to their syllabi. My name is Mr. Pochilola. I decided to make this video for Form 4 candidates who are yet to sit for their Msce exams this year, I think somewhere in July, on a topic called a mathematics topic called theorems. Alright, so once again, in case you are one who is interested in private online lessons, we are glad to present them to you. All you have to do is just contact us on the number shown on the screen. We'll be able to come back to you with the concrete arrangement. So my name once again is Mr. Pochilola. Like I've always said, don't hesitate to subscribe to the channel and also hit the notification bell in order to safeguard your future lessons, so that every time we upload a lesson, a video lesson, you are the first one to see that your lesson has been posted. Alright, so wish you well as you consider to like, subscribe and hit the notification bell. Alright, so since this has to do with circles, as the name of the topic suggests, I felt that it's imperative for me to take you through some important definitions of terms that relate to the circle. Without much ado, let us define the term circle. Of course, your examiners will not ask you to define a circle to say define a circle in a mathematics test paper. No, that cannot happen unless otherwise. But like I always say, that the understanding of any topic lies in the definition of the topic. Alright, so in order to unlock the understanding of a topic, it is important for us to look at some important and pertinent definitions of terms, starting with the definition of a circle. What is a circle? Alright, for the sake of this lesson and the topic, we are going to define a circle as a set of points. Alright, so you have a set of points which are equidistant or the same distance from its center. That's the simplest definition of a circle you can give at the moment. Alright, so a circle, as you know it, takes this shape. Okay, so a circle has a center about which the points are generated. Let's suppose you are drawing a circle using a pair of compass, which is one of the pieces of instruments in your mathematics box. So you pitch the needle of your compass here at the center, and then you open it, your pair of compass wider enough to a certain radius, and then you draw this very nice shape. So it is this shape which we call a circle. All right. The distance around the outside of the circle, which is this distance here, is referred to as the circumference. Of course, it must have a reference point. Let's suppose that you start moving from here, you go round and round and round and round and round, and you get back to the same point. You have covered a distance which is called circumference. Alright, this is called circumference. So circumference is similar to perimeter. Perimeter of a body, remember that perimeter of an object is simply the distance around that object, measured in centimeters, millimeters, or sometimes in large units such as meters, kilometers, and others. Right, I hope so far so good. We've defined the circle there. We've also looked at the circumference as part of the circle. All right. Now, if you draw a line from the center of a circle, such as this distance, such a distance is called radius. So the radius is simply defined as the distance from the center of the circle to the circumference. So if you consider this as a center and you draw a line from such a center to any point on the circumference, such a line, such a distance is called radius. If you have more than one, then you have what are called radii, R-A-D-I-I, radii. Radii is plural form of radius. Okay, so you can have another radius there, you can have another radius this way, you can have another radius this way, you can have another radius, and so forth. But for the time being, we have this distance here, which is just one radius. I hope so far so good. What is a circle? Then what is circumference? Then radius. So far so good. Now, sometimes you may also be interested to draw a line from one end of the circumference to another, passing through the center. Such a line is called diameter. Right? So we define a diameter as the distance across the width of the circle through the center. So we draw a line or through from one end to the other end. It will give us the diameter. So diameter basically is this line. Okay, notice that half of diameter gives us the radius. Okay, so from that point to the center there, that forms a radius, and from the center to the other side, it forms another radius. Diameter is radius plus radius, okay? But it has to be straight line. It doesn't mean that this part is the radius plus this part is another radius, it forms a diameter. No, the diameter must be a straight path, a straight line, originating from one end of the circumference through the center to the other end. So far, so good. Circle we have defined, circumference we have defined, radius we have defined, and then diameter. Take note of these parts of the circle. Right. So we are going to look at the theorems that pertain to the circle. Okay. The first theorem states that the angle in a same circle is always 90 degrees. Consider this circle, which we already have defined, and consider the diameter AC. Okay, and then if we complete a triangle like that, this angle is always 90 degrees. That's a theorem. It's a statement which is true, but we can prove it. We can show that indeed this angle is 90 degrees by setting out what is known as the formal proof. Okay, so we can have a formal proof to ascertain that this angle is always 90 degrees. So in the next slide, we are going to look at the formal proof. How can you can formally prove that this angle indeed is always 90 degrees. All right, so we've just seen that the angle in a same circle is always a right angle, which is 90 degrees. So how do we show this now? How do we prove that indeed that's the case? All right, so we can prove this result as it follows. First, we must have a circle. We must have a circle, and inside it we have a triangle. Part of the triangle is diameter, so we have a diameter AB. all right? And then we have other sides that complete a triangle. So this angle here is the angle that we are interested in, this angle here, the angle ACB. That's the angle we are interested in, okay? Want to show that this angle is 90 degrees. Okay, so how can we do that? Sometimes you'll need to draw additional lines to a given diagram, which is going to help you to set out your formal proof. All right, so to this diagram, we are going to add a line. You draw a line from point C, draw a line from point C to point O, okay, all right, which is a radius of the circle, okay, like that. Okay, so in so doing, what we've done now is to create some triangles. Okay, of course, if I ask you how many triangles we have here, you notice that we have 3 triangles. We have triangle ACB, we have triangle AOC, we have triangle BOC. So it's like we have 3 triangles there altogether. But our interest for the time being is triangle AOC. AOC. So in the triangle AOC, you do agree with me now that line side A or line OA, this one here, is equal to OC. Both of them are radii. So there's one radius here, there's another radius. Remember that radius, radii are equal. As long as they are originating from the same point, which is the center of the circle to the circumference, they are equal in length. Okay, so we are interested in this triangle here. If you like, I can shade it like that. That's the triangle we are interested in. Okay, so with that triangle on your mind, we are saying that this side here is equal to this side here. They are radii. Okay, they are radii. Okay, so if that's the case, then we can very assuredly say that if these two are radii in triangle AOC, if this is equal to this side, then we can conclusively say that angle OAC, which is this angle here, is equal to angle OCA, which is this angle here. These angles are called base angles of isosceles triangle, such that if we mark them, that means each angle can be marked the same way. So we have an X there and an X here. This triangle AOC is isosceles. Remember that an isosceles triangle has a pair of sides equal, and the base angles are also equal. All right, so that is it about this particular triangle. Let's look at the same for this type of this triangle here, triangle triangle BOC. All right. So in a triangle BOC, most assuredly, we can also say the same thing that pertained to triangle AOC. So we are looking at this triangle here. In triangle BOC, OB, which is this side, is equal to OC, which is that side. They are also radii. Okay, so that we can conclude without doubt that angle OBC, which is this angle here, is equal to angle OCB, which is this angle over there. These are again base angles of isosceles triangle. Which triangle are we talking about this time? It's triangle BOC. Alright, so if we mark these two angles with the same symbol, or such as Y, for example, then we have these two angles which are equal to each other. Now, I want you to recall that the sum of angles in any given triangle is equal to 180 degrees. I hope you can recall that. All right, so if you add these angles up, let's say we have x plus x, then plus y plus this y here, the total, we're looking at the whole triangle here, ACB or ABC. The sum of these angles is 180 degrees, and that is the basis for our proof. Okay, so if we add those angles, you would appreciate that in a triangle, that's our reference, our triangle ABC, x plus y is 180 degrees. These are angles in a triangle. So if you collect the like terms together, like x plus x, you get 2x, and y plus y, you get 2y, then this is equal to 180 degrees. Take note that we have a 2 here, we have a 2 there. This left hand side can be factorized to produce 2 open brackets x plus y. Okay, from here 2 open brackets x plus y, and then go ahead, divide both sides by 2. You end up getting an equation in x and y. So x plus y is now going to be 90 degrees, having divided both sides by 2. All right, so, but what is x plus y? X plus y, you notice that it's the angle that we were interested in. The angle that we were interested in is this angle here. That's the one that we're interested in, to show that it's 90 degrees, and we have just done that, exactly that. Okay, so now without fear, we can conclude that therefore angle ACB, which is the angle in a semicircle, the angle which is there at the circumference in a semicircle, is 90 degrees. So angles in a semicircle, therefore an angle in a semicircle is all the time a 90-degree angle. We have just shown that. My name is Mr. Pochilola once again. Please like, subscribe, and hit the notification bell so that you become the first one. You are the winner. You become the first one to receive a notification of a new video as it gets uploaded. All right, so that's great. We just proved that. Now I would like us to apply the theorem in solving a problem in which at least the theorem is going to apply. So over here we have a problem requiring us to calculate the size of unknown angles. Okay, so the question says calculate the size of the labeled angles in the following diagram. So in this diagram we have a triangle in a semicircle forming this angle here, which we said is 90 degrees. So A plus B is always 90 degrees, and the condition is this must be a diameter, so that the circle is cut into 2 semicircles. All right, so the only information we know is that this angle is given to us as 37 degrees. So using it, we should be able to calculate angles A, B, C, D, E. There's a lot of doing, but I must assure you it's very easy to do if you remember the facts that we outlined earlier on. All right, so the given angle is 37 degrees, and this can help us to find the angle A. If you look at angle A is base angle with 37 degrees. This angle here and A are the same. Okay, so we are saying this because this side is equal to this side. They are a die, and therefore the triangle is an isosceles triangle. In an isosceles triangle, one pair of sides are equal and the base angles are also equal. So if this is 37, that means this is also 37 degrees. Alright, so the angles at the base of an isosceles triangle. So the triangle that we are looking at is this triangle here, this one. Okay, so this, at least we know A, but we also know that A plus B is 90 degrees. The whole of this angle is 90 degrees. We just proved that earlier on from the previous slide. Alright, so we can comfortably say that A plus B is 90 degrees, but we already know A is 37. We calculated, we mentioned it up here. So we subtract 37 from 90 to get B. So we are saying B is equal to 90 degrees minus 37, which gives us 53 degrees. Where are we getting the 90 from? Because A and B together form an angle in a semicircle, which we said is always 90 degrees. Alright, so with this angle being 90 degrees, if this angle is 90 degrees and this is 37, looking at this whole triangle here, what do you know about angles in a triangle? Alright, if you said that they add up to 180 degrees, that's good. So this is 37, this is, the whole of this is 90, A and B is 90. So we can find this angle here by applying the fact that angles in a triangle add up to 180 degrees. Alright, so even if you don't do that, you can still find C by remembering that this side here is equal to this one. Therefore, we have an isosceles triangle with us. Therefore, angle C is also equal to 53 degrees. Okay. How do we find angle D? Alright. Notice that angle D, we can easily find angle D by applying the fact that angle B, C, and D are in a triangle, this triangle here. Okay, so angles in a triangle add up to 180 degrees. So to find D, simply add B and C, which is the same as 53 times 2, and then subtract the result from 180 to give us the value of D. What do you notice about D and E? D and E are angles on a straight line. So if we know D, we can calculate E by simply using the fact that angles on straight line add up to 180 degrees. So this will give us 180 degrees minus 74 degrees, which is 106 degrees. So what have we done here? We have applied the fact that an angle in a semicircle is always 90 degrees. If that was not the case, we would be stuck here. It would be very hard for us to find B. So A and B are complementing each other. They add up to 90 degrees. So subtracting the value of A from 90, it gave us this B here. So far, so good. My name is Mr. Pochilola. Once again, please, if you have not done so already, like this video and subscribe to the channel, as well as hit the notification bell so that you don't miss any lessons as they are uploaded to the channel. Okay, let's look at another theorem. Remember, we're looking at circle theorems. Alright, there is our second theorem is about an angle at the center of a circle. So we have an angle at the center here, which you have marked in green, this angle here, and another angle at the circumference. Notice that if you look at this, you see already a relationship between these two angles. If this is 90 and this is 45, it means that this angle is obtained by simply multiplying the angle of the circumference by 2. Okay, so this brings us to the second theorem, which says that the angle at the center is twice the angle at the circumference. Okay, the angle here is 2 times the angle at that end. Okay, that's what the theorem is saying. So we'd like also to set out a formal proof to show that this is always true. So how to do it? Do we do it? Okay, so we'd like to prove that an angle at the center is twice the angle at the circumference. So we have just seen already in the previous slide an assertion that an angle at the center, which is this one, is twice this angle here. So how can we show that this is always true? Okay, all right. So as before, you draw a line. We draw an additional line from A to O and then beyond it. Okay, so draw a line from B, draw a line from B, draw a line from B through the center and to the other side, call it D. Okay, so this line is going to help us to prove that indeed an angle at the center is 2 times the angle at the circumference there. Okay, so with this additional line, then we have created for ourselves a triangle AOB. Triangle AOB. We are looking at this triangle here. Okay, so in this triangle, OA, side OA is equal to side OB. Mind you, these are radii. We said that radii are equal. Okay, they are equal. So side OA equals to side OB. Okay, they are equal. So what do you notice? If that's the case, then we can comfortably, without fear, say that angle OAB is equal to angle OBA. OAB is equal to angle OBA. Okay, so these are again angles at the base of isosceles triangle. So this angle is equal to that angle. We can label them with the letter X, then both angles will be marked with the same letter to show their equality. So these two angles are the same. Now we can repeat the process for this other part of the diagram, the triangle OBC, OBC or OCB, whichever order we follow, to show that this angle here is also equal to this angle there. All right. So let's do that. Okay, so in a triangle BOC, BOC, which is this triangle here, side OB is equal to side OC. Okay, so if we use that fact and relate the angles at the base, you find that these two angles, the angle there is also equal to the angle over here. All right, so the angles OBC, which is this small angle here, should be equal to OCB, which is this angle here. These are angles at the base of an isosceles triangle. So which triangle are we talking about? We are talking about triangle BOC is isosceles. So this side equals to that, they are radii, and therefore the two angles are the same. So we can label the angles so that each angle is Y. Now pay attention. Remember that the goal is to show that the angle at the center, which is the whole of this angle here, is equal to the angle at the circumference. All right, so what do we do with these? You will recall from your junior mathematics that this angle here, x, plus this angle here, x, is equal to this small angle there. Similarly, angle y plus angle y is equal to this angle there. That's what we are going to rely on to show that the angle at the center is equal to twice the angle at the circumference. So angle C, angle AOD, angle AOD, this angle here is equal to 2x. We call this the sum of angles, interior angles equals to 1 exterior angle. So this angle here is equal to x plus x. Similarly, angle this angle here, COD, angle COD is also equal to y plus y, this angle here. Alright, now take note, if you look at this angle here and this angle there, there's a relationship there. Okay, so the exterior angle in a triangle is equal to the sum of the opposite interior angles. That's what we just showed there. Alright, now since the whole angle at the center, this angle here, AOC, is 2x plus 2x, okay, you appreciate that the 2 which is common, can be factorized. So you factorize the 2 there, the 2 goes out, and you have 2 open bracket x plus y. But what is x plus y? X plus y is this one here. X plus y is this one over here. And then that angle is multiplied by 2 to obtain the angle at the center there. So it can be concluded that the angle AOC, which is the angle at the center, this angle here, is twice the angle at the circumference, which is that angle there. So that's the formal proof for showing that an angle at the center of a triangle, an angle at the center of a circle is twice an angle at the circumference. Of course, the condition is that the two angles must be faced or subtended by the same arc. My name is Mr. Lola once again. Please like, subscribe, and hit the notification bell so that you don't miss any videos as they get uploaded. Alright, so I would like you to apply what you have just learned in so far from the previous slide about an angle at the center and an angle at the circumference. Calculate the size of the labeled angles in the following diagram. Alright, so please do this one and share with me your answers. I'll be very glad to come back to you with feedback. So for now, let me leave you. Please do this one, pause the video and work on this problem, and let me have a look at the solutions that you get. Once again, my name is Mr. Lola. Please do yourself a favor by subscribing to the channel, and also inform your friends that it is possible to learn on this channel all for free. Unless you want to privately arranged lessons, you don't hesitate just to contact us and we'll be able to attend to you. For now, I wish you the best and we meet in the next lesson.